Hello and welcome back to a C# guide. In this episode I'm going to be talking about floating point numeric types. So there are different versions of floating point numeric types, same as integral numeric types if you watched that episode. But a floating point numeric type represents numbers with a floating point, meaning they have decimal places within them. They do not have to have decimal places, you can just write one out without decimal places, and it could be just fine, but it has the possibility to go to decimal places. So I'm going to start off with showing you just the simplest one, which is a float for floating numeric type, obviously. So the float I'm just going to call f, and I'm going to make this 0. So I can write this out as this. 0 is the default value for a float, but I can write this out like this. But if I wanted to then add a decimal place, let's say 0, 1, this does not like it anymore, because I've now defined it as a float. You can write a float as a whole number, and it'll be perfectly fine. But if you want to add decimal places, you have to add f towards the end. This could be a lowercase or a capital F, but obviously most of the time you're going to be doing lowercase. So a float is the simplest one because it only takes up 4 bytes. You may think that's quite a lot, but that is the same as an integer. So now we know this only takes up 4 bytes, I'm just going to show you what that means, what that actually does mean. So I'm going to write a quick console write line, and I'm just going to put in a float, and I'm going to show you the minimum value. I'm also going to show you the maximum value. I'm just going to copy and paste that and put in max value. And we're going to run this. So as you can see, the minimum value is a negative 3.4028235e plus 38. And the maximum value is the positive version of that. You may be thinking this is not a number. Well, it is not. So the number actually ends at the 5. So this would actually be the minimum. The e plus 38 actually means that it can be multiplied by 10 to the power of 38. So if you don't know what that means, it can move 38 decimal places towards the left. So the range we can actually have is around 6 to 9 digits using float. Next up is double. With double, I'm just going to put 0 for now. With double, we can initialize the same as before using, a D for double or capital D for double. But what we could actually do also is just leave it. Have no letter preceding the number, and the code is going to assume that any decimal without a letter afterwards is going to be a double type. So let's just leave that like this for now. And a double is 8 bytes and can have around 15 to 17 digits. So let's just replace the float and to find the minimum maximum value, and you can see it's a negative 1.7977. This is only 4 decimal places. I'm going to read it because, as I said before, it could be ridiculous. But this is e plus 308. Next up, what we have is even a larger one, which is a decimal. I'm just going to call this DE, and I'm going to call this 0.1. This will not work, same as double, because obviously if we do not have a letter afterwards, then it's going to be assuming it's a double, and a double is not a decimal. So what we can do here to make this a decimal is type M. This could be a capital M as well, but I'll just write lowercase m for me. A decimal is 16 bytes and can have around 28 to 29 digits. So let's just type in decimal in here to get the minimum maximum value. And you can see here, this is the actual minimums and maximum values. So I'm not even going to attempt to read that for now. So you may be thinking, why do we use decimals? Where do we use decimals? We use decimal for financial programs because we need the accuracy. So if you're going to be using a float or a double, multiplication errors or division errors are going to be happening because they'll start rounding numbers. And that's why we use decimals for the precision that they provide. So now we're done with these minimum maximum values, so I'm just going to comment them out. And we're just going to put in a new write line. And what we're going to do in this write line is I'm just going to show you something else. We can use E to our advantage. So let's say we have F up here. I can write F, 1.01, but I can also write, 1.01 E2, for example. and then I'm going to put an F down in our right line, and you can see it's not going to return 1.01 anymore, it's going to return 101. And that's because we have put in our E in here saying this 1.01 is multiplying by E, which is 10, to the power of 2. So that is 100, our 1.01 is multiplied by 100, which is equaled 101. So that's just something I'm going to show you can do now, which will hopefully help you understand what the other things are doing. So something else we can actually do when we're writing out a double, when we're writing out any of these actually I'm just going to put in DE, we can write 1 underscore 000 dot 00, let's just do, actually let's put 01 so it looks a bit better, N. And the reason I have written an underscore, and it's not actually come up with an error, is because it's going to just ignore this underscore. The point of an underscore is so we can read the numbers more clearly. So say I run this now, it's 1001. And that is what I've written, but I've used an underscore to separate out the 1 from the next 3 digits to make it more readable. Something else floats and doubles can do, but decimals can't, is find things that aren't numbers and find things that are positive or negative infinities. So you may be thinking, how do you get infinity in code? How you get infinity is, I'm just going to use F, and I'm going to divide it by 0. This equals infinity. The point of this is we can actually use floats in comparison and equality operations. So we could say, we can check to see if this equation actually does equal float dot positive infinity, and it will return true, and that is the equality there. We can also do a bit more of error checking, not just checking if it's infinity. We can check if things aren't a number. So this NaN stands for not a number, and we can run this, and this is a value that we can have. So what we can do is we can again have an equation and then check if it's actually not a number before we try and do anything else with it and break our code. That's the whole video. I've just talked about the different types of floating points. I've given a little bit of tips. I hope you've enjoyed this. If you did, leave a like on the video.